Hello, welcome everybody on the Simnest Aviation live show on Facebook. We are here in Hot One, our factory, and you can see behind me the FNPT II MCC generic larget device. I will show to you the team who are here. Peter Orosvari is behind of the camera. My name is Csaba Pavlov. I am the Sales and Marketing Director of Simnest Aviation. And my colleague is Miklós Kacsor, CEO of the Simnest Aviation.
Hi all. Let me present you our new wonderful device here in Hot One factory. Okay, so first of all, a few facts about the device. Like it is 6.7 meters wide. It has around 6.5 meters length, so the deepness of the sim is around 6.5 meters, and it's a 3.2 meters height. This is the front plate of the simulator, where you can see 3 doors, each of them having behind them a compartment. The first one is the entrance to the visual room. I will show you in a few moments that one. The second one is the magic is behind the second door, actually, the cockpit and the instructor station. And the third door is actually a door that leads to the server compartment, let's say, put it like that. And it has the HVAC tubing and things like that. I will show you that as well. So let me begin with presenting around the device itself. And we will take a look in the visual compartment. So all doors are sliding doors to save a bit of space, because actually it's a quite huge device. I don't know if it's you get it on a camera, but it's a quite huge device. So this is the first compartment we have. All compartments are equipped with lights, so with technical lights, so you can have. Okay, so this one is actually almost empty. This small device in front of me, it's a nuclear reactor. This powers the simulator. No, it's actually it's a compressor of the oxygen masks, because in this particular device we had to implement fully working face masks for pilots with all the functions it has in an original A320 aircraft. So we had to adapt compressor to the needs of a breathable air. These filters are for that purpose, actually. The compressor itself will be outside of the compartment right now. It's here. If it starts, I will jump up, because it has a quite high. It's quite loud, but right now it's here for just demo purposes. But usually it sits outside of the box for not to hear it.
Guys, this is really important, and we are just over or after the factory acceptance of this simulator.
Yeah,
so it is not the final places where we keep these things. It will be out of the simulator, and of course it is not the final
setup. Okay, I will tell you a few words about that, because sure, all our simulators are built here in our factory in Hot One, and we let our users to come here and check everything. Actually, they make a full acceptance like at home, and they can check everything, because it's much easier for us here to correct the errors if they are, and they can see what they buy. So this is a very important thing, that before we even put them on truck and transfer it to the site, we make a full, a complete build-up of the simulator, so our partners can check here the device they have. So, but we leave out a few, let's say, cosmetic-like things, just for the sake of simplicity. We have to have some walls here. Some walls will be fixed here. It will be tidied up a bit, but actually you see the same simulator as will be in production when we have it working in the ATO.
Yeah.
Okay, so let's step one room. So here is the projection room. It has a dimension, actually, which is based on the, actually the FAA regulation has a number to have the projection, the parallax error less than 10 degrees. This makes 6.5 meters wide, need for a 6.5 meters wide projection surface. So it is a quite huge building actually. If you please put the lights on, please, and then you can show the roof. So yeah, so it's everything is built on with aluminium elements. Everything is painted in black here because it's quite important to have a good picture.
Yeah.
Okay.
That's really important that we are using Epson laser projectors, and we have a strategic partnership with Epson, and that's why we are using these high-end projectors, which are showing us this beautiful picture on the screen.
Okay.
Yeah.
Okay.
You will see that it's really nice, and yeah, it's beautiful.
Okay, so as we go further in the projection room, wow, there is another entrance. Yeah, it's like a dome-like. We have a service light here as well. This is the so-called mirror space station. These tubings are actually for HVAC, for heating, ventilation and cooling. It is very important because the projectors are laser projectors with a very high luminosity, and they create quite a lot of heat. So we have to dissipate that somehow. So these HVAC and ventilation things are integrated in the simulator, and it's controlled. Everything is controlled. This is the brain of the device actually. Everything which is, let's say, active elements of the simulator are placed here. So if you can come a bit around to show the device itself, it's not a big place to be, but yeah. So here you can see actually is an IT rack, and every active element, even the power elements for the control loading of the rudder is located here, and everything is cabled from here. The simulator must be very, very modular because, well, if you think we built up here and we have to disassemble everything and take it to the customer and assemble it once again. So this means that every cabling, every let's say equipment must be very, very tightly designed to be transportable. So it must be quite modular. So this IT rack will go by itself actually, but yeah. So it's everything is quite modular. Okay, Csaba, you stay there or?
No, I'm coming.
Can you please close that door as well?
Yeah, sure.
Okay. And well, behind this door is the magic. It looks very nice, I think. So I'm very proud of Simnest and our company that we could make that possible.
Yeah. As you can see, the training in progress. So it's coming.
That's the nicest training in progress sign. Okay, so what we have here is the instructor box and the cockpit itself. The simulator is built for training, so it's very important for you to know that we try to do everything for our instructors to feel good in their work. So this is why we try to make everything very simple for them. We have a lot of we put a lot of effort actually to make the simulator usage very, very, very simple. The first thing you notice here, we have a touch screen, and actually from this touch screen you can start and you can stop the simulator, and you can do a few let's say workarounds, like you can switch the projectors on or off. You can turn the force feedback off because because there is a regulation. Actually, you have to have force cut switches We have two one on the cockpit, one behind the instructor table. And you can, if you push that because you need, then you have to restart the force from here. So you are not allowed to restart from the same place as you stopped. Okay, we have some ventilation speed. I will put it to high. Then the ventilation will go for a higher level. So actually, here is the control panel. You can start and you can shut down the simulator with one push of a button. You don't need to touch any pieces. You don't need to switch on, switch off things. And actually this interface is accessible via a web server for our maintenance personnel as well. And this is quite important because we can actually log into the simulator and check lots of health status of the device. We can log a lot of possible issues, and we use it for our maintenance purposes a lot. So that is the control panel of the simulator. Okay, let's go a bit more deep in the technical stuff itself. Here is the iOS. Actually, this is a double screen. It's a touch screen. Actually, you can have a lot of space, and it's quite easy to use instructor station. Here you can see all of the functions of the simulator. Here you can interact with the trainees. Here you have the systems. I will come back to that later a bit to show you what kind of systems we can manage. But actually, we have lots of failures, possible failures, and simulated failures. So from this iOS, we can make almost every failure we can imagine. Let's say we will do a test flight after that. So I just show you some how it's done. Like I would like to have, no, I don't like to have, but I will I will show you how to make an engine failure, let's say for engine number 2 with damage, no relight, after V1. So I arm the failure. Now you can see that it is in amber. So as soon as the aircraft will accelerate beyond V1, it will go up the failure, and I will have to handle that. Okay, so this is the screen where you can set errors, you can set failures, and you can manage the session itself. This one is a map. It's actually a map. It's quite good because you can see the already loaded flight plan. You can see we put a cumulonimbus in the vicinity to have something on the weather radar. I can show you the weather radar. We have this quick access bar where you can see all the airports that are programmed in the FMGC. You can see those airports weather, and it's very good for the instructor if he has to give weather reports for the crew. Actually, we have implemented, and we have a working ATIS, so I will show you that one as well. Okay, here that was a requirement to have at least a navigation display and a PFD of the simulator on the iOS for the instructor to see how the pilots are working. Okay, just this is I think it's okay for the from the iOS part. One very important thing that it is a FNPT II MCC generic simulator based on Airbus A320. For FNPT MCC level simulators, you need to have a complete intercom and radio system working. Actually, we went beyond the legal aspects of this requirement, and we implemented a fully working zero latency. So based on hardware mixer, we implemented a zero latency intercom and radio system in the simulator, and the instructor has the possibility to use a few interfaces to communicate with the pilots when he wants to, let's say, simulate an ATC, or even to communicate to only one pilot for pilot incapacitation training, So we have lots of possibilities here. So we have a normal hand mic, and this one is working. So okay, so we have a hand mic with a button like on the original aircraft, and we have a headset as well with a software PTT, and this can be used by the instructor to simulate actually almost any situation. On the communications panel, you see a fully featured ACP, audio control panel, and this is the fourth ACP, let's put it like that, because we have a third in the cockpit, but here is the fourth ACP, and this can be tuned to act as ATC, or act as Intercom, or act as an instructor. So we have lots of possibilities here. It's a quite complicated system, and we, as I told you, we went beyond the legal requirements, and we implemented the fully working A320 ACP and intercom system. So every, let's say, button works like it should. So actually, this is for the intercom system. I will show you a few other things around. Okay, let's get to the cockpit a bit, okay? Because this is, I think, why almost everybody is here. Right now, for all our high-end simulators, we are using a few original OEM components because of sturdiness, first of all, and second, believe it or not, one of the most complex things in this cockpit is the seat itself. So actually, this is an original Airbus seat. It's something that we had to implement. It can be used by electric movement, so it is moving electrically and mechanically as well. So actually, it's a 100% Airbus seat, and we implemented the all its functions. Back to some other things. As you can see, I just opened the tray table for you because we have tray table as well. We believe tray table is not something you eat on; it's something you put checklists, and it's a part of the procedure. So maybe for you it's maybe it seems not that important, but it is important, because if we want the pilots and the instructors to believe that they are sitting in a real aircraft. And when the procedure says that, okay, put your, I don't know what kind of document and write things, or write down the fuel, or write, let's say, during an APS course, let's say you have to write a flight plan, then write it like in the aircraft itself. So this is why we implemented everything. The foot rests are working, and tray tables are both of them working. The tray table lights are working. They are absolutely there where they should be. Okay, on the other hand, let's begin from the back. We have, which is very important feature of the simulator, we had to install the oxygen masks. I told you these oxygen masks are original Eros aircraft oxygen masks. So if you look beyond this, behind this door, you can see the original masks inside. I will just show you the test procedure for the mask. So you have to put intercom mechanics, and you have to have the loudspeaker volume set up. Okay, and then when you push this button, you can hear the sound of the mask here, and you can hear the sound of the mask in the speaker. And this is very important because this is how you test that the microphone of the mask works correctly, and the mask has it is pressurized, and you have oxygen in the mask. Okay, so this is the original mask. We will come back to this later because we will fly a rapid decompression for you to see how it works, and I will use the mask actually. So we try to be as close as possible to the aircraft itself. Okay, so back to the intercom. This is always like that. So you have the headsets for the pilots. You have the microphone, the hand mic for the pilots, and we come to one of the most important part of the simulator is the flight controls itself. They are fully manufactured by us. So the flight controls are let's say very close replica to those of the aircraft. I can say that it is, if a pilot sits in this seat, he cannot tell if it's original or not. And I know many companies are saying that, but believe me, this is true. Okay, so we have all the breakout forces, all which is very important, the dynamic, the speed of the side stick, how it lets you handle the aircraft, and you feel the big movement of the aircraft effectively in the side stick. So they are absolutely built by us, and they're absolutely marvelous. It's a 10 kilograms device below that box, so it's quite quite big one. The other thing which is very important, as I told you, we come to flight controls, I think, is the rudder itself. Maybe if you can make a bit of light here, because yeah, it's quite dark here. Actually, I will try to put the lights a bit on, but it is so. One of very important things in the aircraft, to sit correctly. It is very important. For the first time you sit in an all aircraft, if you do a PPL and you fly Cessnas, the first thing you learn is to sit correctly in an aircraft. That means you have to be able to make yourself in a position where you can access every flight control as you have to access. And it is a very important feature for this simulator that we implemented the rudder adjustment. Actually, the rudder is very similar to what you see on an original aircraft. So the setting the rudder is absolutely the same as you do it on an original aircraft. So you can set the flight controls, you can set your positions, the correct position. This is very important. Actually, behind these rudders there are two around 90 kilos mechanics below the floor. So this is a quite big thing, and a 2 kilowatts motor, servo motor, is making the force feedback of the rudders. Sure, the pedals are connected between each other, and the brakes, the pedal brakes are also. So if I push the brake here, you can see that it's connected. Okay, I will let the accumulator there. Okay, so this is what we have. Well, and the most important footrest is working like it should. Okay, good. You can switch that off. Thank you very much. Okay. Well, the other part of the hardware is a very high quality panels from a very good manufacturer, and we try to make everything work like on the original aircraft. And it's very important to have a good look and feel of the panels, and we can say that we are very happy with this one. Actually, what is quite important related to an aircraft environment, and that is very important related to training, that all of the lights, I mean everything, can be switched on, dimmed, like on the original aircraft. So actually, all of the lights, even the checklist light, which is it cannot be used because we have this EFB here. But actually, it is working, and it can be controlled like on the original aircraft. And all of the panel lights, the FCU lighting, the tray table lights, and every inch of the simulator is working like it should. And they are connected to the appropriate AC, so the AC buses. So if there is a failure, if one of the bus fails, which powers one of the backlights or panel lights or integrated lights, then they will switch off. So this is for training, and it's very important, I think, if you train during the night time, to have the possibility to dim the lights to the level that you see the most higher contrast in the cockpit. Okay, maybe a few words. We try to make another very important feature of the simulator. However, for Airbus, you don't need to have, or Airbus-like generic, but it's Airbus-like simulator. You don't need to have working CBs like circuit breakers. But because we in our portfolio we have FTDs as well, flight training devices as FTDs. There we had to implement the circuit breakers, and this is why we put a few circuit breakers here for training purposes. So actually you can use this circuit breaker panel as on normal full flight or any other flight. These are just a few CBs are implemented. I'll try to find one. Yeah, here FCU. So if I pull this out, I can pull it out. You will have the ECAM out of flight FCU1 Ford. You know, the CB itself, CB out will come on after only 1 minute. This is how the ECAM logic works. So you can push back the CB and you can see that the fault disappears. And it's a quite important thing I want to show you. Let's just switch places, okay? So you can pop a CB from the panel, iOS panel as well. So if you hit trip, just show them please the same CB, okay? And if I push activate, it will come out, okay? So it can use actually for training purposes, for electrical failures and computer resets mostly. So this is how CBs can even be popped, and they have the effect, the desired effect. So everything is like yeah. One feature, and as I told you, we have to have some buttons for the instructor to switch the power off and on for the flight control loading. Actually, this will switch off power for every mechanically activated device in the sim. So if you push this, it will switch off the rudder control loading, the seat motors, and the trim wheel as well. So these three things are switched off by this button. But we have one more important button. If you push here, the instructor light will you can switch the instructor light from here as well. And it is very important to dim the light. It has to be has to understand that this is a training environment, and if you have, yeah, shut the door please, yeah, it's better like that. Yeah, so this is a training environment, you know, and when you train night sceneries or during the night, you have to adapt the instructor box light amount and the cockpit to the outside amount, okay? So it is very important that this is not just it is a requirement actually from every instructor to have the possibility to set the light as it should. Okay, so I think right now we are ready for a small test flight. I thought that I will make I already prepared the aircraft for a pushback. I will make just a short taxi to show you around a bit the airport and to show you the lights and show you how they work, because it's very important. And after that, we do a takeoff. One engine will fail, as you know, because flying normally is for faint-hearted. We are strong, so we will begin with a failure. Okay. Then I will show you a bit of some electrical failures. Then a rapid decompression. I will try to reposition the aircraft just to show you that. I don't want to take up time by taxiing for a long time. Okay, so here I am. It's already the FMGC and the MCDU is already set up and prepared. This is Brussels Airport. The weather is quite intriguing because we have some storm now. As I told you, all of the ATIS frequencies are working like they should. So we can even check the ATIS for that.
10 degrees 10 knots. Visibility 10 kilometers. View 3,500 feet.
Okay, so it can be heard that
temperature plus 10 degrees. Dew point
it has
minus
an
5
auto-generated
degrees.
ATIS.
UNH1010 millibars. Cumulonimbus in vicinity.
Okay, so this is an automatically generated ATIS message. The instructor has the possibility to add or to edit this message. Okay, I will set that. Okay. Good. So this is Brussels airport. I prepared the aircraft for a trip to Budapest. We will have some failures, so we will not make it. I just really want to start the pushback and things like that. May I put the lights a bit darker? It's okay, you can see?
Yes.
Yeah. Okay, so let's keep the procedures because it's just a demo of the simulator. I don't want to do many procedures here. Okay, so I will ask the ground to for a pushback and for start. We got the pushback and start clearance. We put beacon on. We already have APU bleed and ground control. And okay, so
release parking brake.
Parking brake is released. Okay.
To the left or to the right?
Well, to the left. Okay, just push. First push in the. No, first push straight. Please, yeah. Okay. And then to the other direction that you pushed previously. Okay. And I will tell you when to stop. It's actually the. Okay, so we can start the engine, starting engine number 2. Okay, please do a bit of more push. Okay, you can stop the push. Okay, engine number 2 is starting. The starting cycle, you can check it's as the original with all the EGPs and things like that. May I set the parking brake?
Yes.
Yeah. Okay. Parking brake set. Okay. So, one important feature of this simulator is that we have implemented the lights, airport lights on the simulator, which are absolutely so the instructor can switch them on, switch them off, can dim them. They can make a lot of stuff. I will start the engine number 1 as well. Starting engine number 1, and I will ask Peter, the cameraman, just a bit. I will show you the lights panel itself. Okay, just let me until it starts. I know it's not standard, but let's leave with the standards. Leave the standards to the pilots. Okay. So here we have on the airport tab, there is a selected airport, which is now Brussels, and you have the show lights button. And then just if you look outside, maybe you can show them, Peter, that we can see the green taxiway lights on the visual. And with this button, we can switch them off. As you see, we can switch them on, or we can dim them back. So actually you have control over runway lights, PAPI, VESI lights, approach lights, taxiway lights, and stop bars. Our simulator is actually capable of Cat 3 low visibility operations as well. So so actually we need these possibilities, and we can set everything correctly to the situation we use. We already I will like have a bit of stop bars, close lights. So you have the possibility to modify the intensity of the lights. Okay. Okay, we have 2 good starts. This is the full procedure. Okay. So we are almost ready to go. We will ask for a clearance. Simnest 1 after pushback. Request taxi clearance runway 25 right. The instructor can say taxi 2 straight, then left. I don't know the taxi procedure, sorry here. Okay, then ready for taxi.
Ready.
Okay,
Go.
then taxi lights on, parking brake release. Very important thing that as a A320 with this weight, it should move. Yes, if you look outside, it moves without adding any power. It's very slightly, but it moves. It should. We implemented all of the performance is based around the original aircraft. So it is that in that particular matter you can use the tables from original Airbus QRH for the settings. Okay, let's do a brake check. Okay, brake check. Let's do a control check. Full left, full right, neutral, full down, full up, neutral, and you can and push the button, and then rather full left, full right, neutral. So we did the flight control check, then auto brake max, takeoff config we can do if we want. Okay, you should do, but taxi checklist, but it's flight controls check, briefing confirmed, ECAM memo, takeoff no blue. So taxi checklist completed. I just show you that we have the checklist folder as well where it should be. So it is very important. We try to keep everything as in the in the original aircraft. So here is the checklist folder, and even we have the pen holder where it should be. So you can. It's a very familiar cockpit for those who are flying Airbus. Okay, just yeah, we have to taxi, I think, to the other taxiway. As you can see, right now it's quite, let's say, bad weather. We have a cumulonimbus around, and we will have some problems at takeoff as well, but I will show you the weather radar immediately just to check out what we can do with that. Just let me have taxi to the proper place. Okay, so right now the weather radar is off, as you can see. We can switch it on. We have another panel. This is a simple one. We have a predictive wind shear weather radar. Okay, so right now you can see that we have the cloud cell on the radar. This radar actually can be used for weather avoidance. It's not there for real weather radar training, because that should we can do that actually, but it needs lots of licenses from the weather radar manufacturers and things like that. So this is why this one is very okay for weather avoidance, adverse weather avoidance training. As you already, I told you, every button, everything should work. So actually the dimmers of the PFD, ND, and things like that are working as they should. Okay, I try to check the bit. See, yeah, straight. Okay. Okay, so first to the left, confirmed. Okay, so we have a cell. I just wanted to show you the weather radar itself. Normally you won't take off, I think, when a cell like that is over the airport, but right now I think we can do a small, just for fun. Okay, runway 0225 right identified. Okay, we stop here and we tell the ground that we are, and they give us the takeoff clearance, so we are clear to take off. All lights on, that means all lights on. Takeoff, cabin crew takeoff, and take us to TIRA. Okay? Yeah. So, and the takeoff checklist, let's do that because that is important. Okay? Cabin, it's secured. Radar, it's on, we need that. TCAS, TIRA, and takeoff clearance received. Takeoff checklist completed. Okay. So, you're ready?
Ready.
Runway 25 right identified. It should be a number there as well.
25 right.
Okay, right side clear, left side clear. Okay.
It's just lighting around us, so
yeah, it's lighting
not the
around
best conditions, but we're trying to.
We will survive, I can tell you.
Yeah.
Who knows?
It's a fixed base simulator, so.
Yeah, but you can feel that it's moving actually. Yeah, if you see in front of us, there is, yeah, possibility. Okay, ready?
Ready.
Set the initial thrust. And take off. Manual flex 65 SRS runway auto thrust blue. We have a bit of wind coming from the left. Should come from the left. Checked.
Check.
One. And rotate. Okay, so we have an engine failure right now. I'm pushing the pedals right now. Just if you can come here, you can just see that I'm pushing the pedals. Not. I think positive climb gear up, please.
Gear up.
Out. That's great. Heading. Okay, so right now I'm pushing the pedals and I have to trim the rudder. Okay, I'm trying to keep the beat target centered. I'm quite good at it, to be honest.
Engine to fail.
Okay, and right now I can leave the aircraft to fly because the rudder actually is trimmed. Okay, we can put AP2. That was not that good trim, but okay. So I will do the ECAMs. I know that it should. Yeah, okay. Let's do a bit at least. We are above 400 feet, so we can confirm the failure. We can see the generator is in fault. Yeah, it's with the damage, it seems. This is what we actually wanted from the instructor station to do. So ECAM actions. Engine to fail. Engine mode selector ignition. Engine mode selector ignition here, or yeah, you can make a bigger picture. Yeah. Thrust level 2 idle. Confirm thrust level 2.
Yeah. Confirm.
Say confirm, please.
Say confirm. I'm sorry.
Okay, thrust level 2 idle. If no relight after 30 seconds, it's already left. We have more than 2.5 minutes in the air, so engine master 2 off. Confirm engine master 2.
Confirm.
Master 2 off. Okay, if damage. It is damaged because we can see crosses actually on M1, so it's something that is damaged. Engine 2 fire, push button push. Confirm engine 2.
Confirm.
Okay, agent 1 after 7 seconds discharge, counting. Agent 1 discharge. Okay, engine secured, stop ECAM. Simnest 1, mayday, engine failure, standby. So we will wait the engine out acceleration altitude. That is around 2,000 feet, I think. Sorry, I don't have a performance calculation tool right now under my hand, so it should be around 2,000 feet. Hopefully. Okay, we will wait that. Okay, 2,000 feet, push to level off. Vertical speed 0. We can see that the aircraft accelerates. As I told you, the mode, the way how the aircraft behaves, even with single engine, it's very similar. It's actually the same as you can find on the full flight. The flight system is tuned with pilot inputs, many input data we have, so it's quite close to what you expect from an original aircraft view. Okay, I'll just do this. We are speed is checked, flap 0. Okay. We are approaching green dot speed. I will open climb, lever MCT, that is climb, and back to MCT, to thrust MCT, open climb. And I will set a lower altitude so that I don't want to climb to 6,000 feet. I don't know, maybe 3,000 will be okay. Okay, speed out star, it was very close. And then in our procedure, we just go direct. I will activate the secondary flight plan. Okay, I activated the secondary flight plan and direct HUL. I confirm that, and we will go direct HUL and hold. Okay. I will set manually 220 knots. And because right now everything is set, I can communicate like Simnest 1, direct H Hotel Uniform Lima VOR and hold at 3,000 feet standby. Okay, so we are going direct HUL. Everything is okay. It seems that we have a CB there, a cumulonimbus. I will ask Patty, please get rid of that cumulonimbus just on the map. Just hit the cumulonimbus and thank you. Good. So now back to ecam actions. Okay. Engine 2 fail. Okay. Clear engine 2. Clear.
Clear.
Okay, engine to shut down. If no fuel leak, okay, we will check the fuel page. This is where the table comes to place, and I can just set everything like big one, and I can, oh, sorry, and I can write the fuel 2280 left tank, 3180 right tank, and a fuel flow is, yeah, it's like I don't have to say that. Okay, so it's just I just wrote two numbers, and we will come back that when we do the load dial. We won't do that, but actually I just show you. This is why the table is here. Okay, as you see, we don't have the CB right now in front of us. The cumulonimbus is out. We deleted that, but we have a small cumuluses with rain. I don't know if it can be seen on the video, but it's raining. Actually, this is why we have on the weather radar this whole thing. I will put the manual again a bit down to have. Okay, so let's continue with engine to shut down. Decam, imbalance mode. Okay, TCAS mode selector T8. Good. T8. Cross bleed shut. Air conditioning cross bleed shut. Okay. Avoid icing conditions. Right now it's 11 degrees. Outside it's 10 kilometers of visibility. Some rain, but there is no icing condition. Okay, so clear engine to shut down.
Clear.
Secondary failures. Land ASAP amber, and we have ELAC. You can see that generator 1 is supplying the whole system, and this is a not good thing. So I will start the APU for us. Okay, to have some spare electricity if by any means generator 1 will fail. Clear ELAC.
Clear.
Okay, hydraulic. The green system is supplying the yellow via the PTU. Actually, the hydraulic system is based around the performance of the aircraft. So actually, if the turbine would rotate, so you would have, let's say, an N1, like now we don't have, then the hydraulic generator, the hydraulic pump, will make some input, so you won't see this kind of PTU working all the time. So it's very complex actually. Okay, nothing to do with hydraulic. Clear hydraulic.
Clear.
Okay, air bleed. Well, pack 1 is supplying the whole system. Clear bleed?
Cleared.
Okay. Status, sub status, any paper checklist, any computer. We had no paper checklist, no computer assets. Actually, we don't have a after takeoff checklist. This is why I tell you that no paper checklist, no computer assets, and I know there are no OABs. Okay, so read status, avoid icing conditions. Well, thank you. If no engine to damage but is damaged, consider engine relight. Don't consider that. Cat 3 single oil, that is for us. Yeah, and some inoperative systems, wing anti-ice, Cat 3 dual engine to bleed back to gen to yellow yellow engine to pump, and so on, so on. So I can clear that, okay?
Clear.
Remove status. And econ actions completed. And it says set hold speed. Okay, so right now we will enter in the hold. I don't really want to take time with this one, so we can go back to the airport. We can land. So everything is like a normal session. Okay, so this is how an engine failure looks like. It's a very important button on the sim. If you push that, we pause the sim. Okay. Okay. So now what I want to do is to even pauses the rain. You can see. Yeah. So what I want to do right now is to get rid of the failures we made, and climb a bit and show you another failure right now. We have a reset failures button here. So if you push that right now, all failures are reset. The engine won't start from itself, but it is reset. So we put everything back to normal. Yeah, put that please up. Okay, this one. We have the okay start for. I don't. Yeah, this one. TICAS. Yeah, 11 MCT. We don't know that leave that like that. It's okay. And then we can go to start engines. Okay, and now we have 2 working engines, and we are back alive. I pull heading, and let's say just for joke, let's just do some flight here without flight plan and things like that. Last time open climb heading. Okay, so now I will climb to flight level 310. What is important? Let's see, climb mode, engine mode. I just want to put some waypoint. Okay, so thrust time, open climb, nav. There you go. I just put a waypoint there to have managed modes available. Okay. So right now it's like a normal flight. I just switch this weather radar off because we don't have. Maybe we have some adverse weather. It's not that bad actually. Okay. QNH set standard. Okay, standard set. Course checked. Passing flight level 5.2. Now, okay, we passed flight level 5.2, and we are climbing to some waypoint. Okay. What I want to show you actually, first of all, that we are right now in a layer of some light turbulent cloud, and you can see the turbulence itself. It's simulated actually by we have a special weather engine installed in the sim. And many effects are generated by our system, and this turbulence system is ours as well, so it's highly flexible to make any inputs our users want to. So if they want some other type of turbulence, or they want to teach upset during turbulence, we can implement almost everything, because the flight model and the whole software is our own, is in our hands. It is our own development, and we can add, and we can do whatever our customers like. Okay, so now we are going to a higher level just to show you a few things. Yeah, everything is set. We will pass flight level 10, and okay, we can switch the AP off because we don't need that. Remain from the previous. Okay, let's say it's flight level 100. Landing lights off. Airport, our side, seatbelts off, and rod nav clear. Rod nav. And okay. So now we are above 100. So Patty, could you please? Yeah, not yet. Could you please just make an AC bus 1 failure or something like that? Something like that. Oh my god, we will all die. So this was the AC bus 1 failure. Actually the auto flight AP went off, all the lights went off, master caution and things like that. We are in thrust lock. So first of all fly the aircraft, so my controls, okay. So I will fly the aircraft and I will set the thrust to the detent we want, okay. So now the thrust lock is off, good. And now I know that it's AC bus 1 fault because it okay, auto flight AP off is on the ECAM, so I fly the aircraft right now manually. Okay, confirm the failure. Yeah, we have actually lots of inputs from the primary failures on the overhead panel. We have the blower fault, we have the electric pumps, and this is most important. We have generator 1 fault and we have IRS on batteries, quite important actually. So we confirm the failure, ECAM actions, auto flight, AP off clear, clear. ELEC, AC bus 1 fault, blower override. Blower override, clear, ELEC, AC bus 1 fault, clear. ELEC, generator 1 fault. Generator 1 off, then on. ELEC, generator 1 off. Then you can see that then on. If unsuccessful, generator off. It's unsuccessful, so we switch it off. Gen 1 fault, auto flight, clear, ELEC, generator 1, ELEC. Auto flight, auto thrust off. You already know that. Clear auto flight. Okay, auto flight. FAC 1 fault. FAC 1 off, then on. FAC 1 off. Okay, it's off. Then on, and we should get back with the IAM. So FAC 1 is working, so we got back our other let's go anyway. Secondary failure. Avionics vent, we switched off the vent, sorry, the blower. So this is why we have a inlet problem there. Okay, clear. Avionics vent. Fuel. We have a few low pressure pumps. In the center one, we don't have fuel, so this is why that is inoperative. Those are low. Okay, we have a blue electrical pump failure. Clear, hydraulic clear, flight controls, spoilers 3, and all the blue systems are gone because of blue system failure. Okay, clear. Status, stop status. We have a lateral discontinuity ahead, so I will just make some waypoints here to stop ECAM. Okay, so right now nav profile. Okay, okay, max brake pressure 1000 psi, landing distance procedure apply, cabins all that fixed temperatures and back sensors. So what you can see from here, I don't want to read all of that, that actually with the AC bus 1 fault you have auto thrust and you have AP2. So actually right now thrust line AP2 auto thrust is on. So this is what is important. So now we have an AC bus 2 failure. This is how it looks like. Okay. So, let's just reset this failure as well. This one should continue and make assessments on things, but yeah, right now we got back everything. Okay, I am trying to reset back everything we had before, yes, and, okay, and now it's all. Just a moment, I'm trying to. go back to the airport. Yeah, it's behind us. Sorry. I will just take it in my hands and do a heading, left heading. I just want to go back to the airport where we came from, and let's just do one thing, and then we are quite good with the flying. Can you please just insert the rapid decompression, because we are quite good. Speed workers. Okay. Oh my God. Master warning. Cabin pressure. Excess cabin altitude. So the first thing you do is shout and get the masks. So you open the mask cabin and you like that, and then you have the oxygen mask and you can go.
Okay, now it's at limit. Right now the left microphone are on, these are open. So it's now the procedure that is made from the mask itself. I'm going to put the how do I look like? Turn, pull. This is the procedure, and before flying I will put maximum zone, value on that zone, things like that. Then we can continue with the connection. I can make mayday call, mayday, Simnest 1, that is the compression from right. Okay. And there is nothing else to do, just wait for the aircraft to go below a safe altitude and refine a bit the altitude. If the lowest on a 0 central or flight level 100. Right now the lowest on a stay here is very low because there is nothing around. And this flight is 1,800 feet, so we can go, let's say, to 5,000 feet. Okay. So right now we will reach 5,000 around the arrow, so we can do the deconnection. Two oxygen in the stone, over the on, descent initiated, emergency descent flight level of 100 or MEA, to the MEA. Speeds not appropriate, they are there actually. Engine will select for ignition. ATIS notify already notified, remove cabin pressure removed. Okay, and passenger oxygen mask one online already through this, but this system is on. Okay, so connection completed. And now we can check the cabin pressure, how it's doing. And we just wait to go, cabin to go below 10,000 feet, and we can get a mark off because it's a bit. Sorry?
We didn't hear.
Ah.
Take off the mask.
Oh. Good.
So just, oh my God.
We take off the mask
better.
because,
Okay.
yeah.
So what is very important right now, this microphone works, and because the mask is open, you cannot use this one. So you suddenly you can do whatever you want. It's not working. So you have to reset the mic back to this one. If you show the mask box, the procedure is to close the mask door. You just put the mask down and you push. You see this flag here. You push this button, and then you will have okay. And now I have this microphone back. Okay. So this is how you reset the mask. Okay. So we are quite there. I will just make a short landing, and I will show you a bit around. Okay, we are below 10,000 feet. Let's put that there. We can have ILS, and we will go back to airport. Charlie Foxtrot 25 right. I will sequence the flight plan. Charlie Foxtrot 25 right, and it's 25 minus 180. It's it's 70. Come on. I don't know. Sorry. 065. Okay, so I extended the center line, full heading. And below 2,000 feet, 2,000 feet. Okay, I check the performance.
25 right, approaching use ILS Zulu, wind 210 degrees 10 knots, visibility 10 kilometers, view 3,500 feet.
Okay, this is all. I have, and QNH is 1010. It's important. Okay, so we just turn left heading 210 and cleared for ILS approach runway 25 right. So we push approach AP1 and 2. And alt glide slope look blue, cat 1, AP1 and 2. Slope. Okay, so we are 20 miles from the localizer. Actually, everything is yes. Okay, then I can activate the approach. And then we are with a failure. We didn't with a failure. Okay. Because we had a rapid decompression, we can suppose that we have some problems with the airframe, so we don't want to overstress the airframe. So I will be a bit more careful with our flight. I will check if yeah, let's just go around this cloud because it's oh, gold star. Okay, let's leave it like that, it's not a big one. You can see on the weather radar there is actually no problem there. Okay. Then, just glide slope star lock. The speed to go below the VFE next. Okay, we are there right now. Okay, and we can put flaps 1. Speed is checked. Flaps 1. Glide slope. Actually, we are now 30.4 miles from the threshold. Was 249 or yeah. Should be okay. I'm just quite of easy part of the situation that we have autopilot. I will disconnect just a bit to show you Cat 1. So what it is very important that the aircraft's behavior, it's very similar to what you can expect from an aircraft like that. So if you check, even it's a bit turbulent weather, you can see that I'm not really touching the flight controls, and it should keep actually below 200 feet because it's so-called C-star low. It should keep actually the vertical speed correct. Okay, I will try just to slow down because we have to put the flaps too. Okay. It's not that conservative. Flaps too, please. Flaps too. Flaps too. Okay. And gear down.
Gear down.
And set the lights to taxi lights. This one to taxi and that one to on. Okay, I don't want to lose the rest of itself. Okay, and arm the spoilers that you just go it up. Yeah, like that. So actually we have a quite big speed. It will be okay. Good, so now I'm okay.
2,500.
Run out. And flaps 3.
Flaps 3.
And wait a bit. We have the pitch effect for the flaps, so actually it's very similar to what you feel in a real one. And flaps full.
Flaps full.
Okay.
2,000.
Yeah, a very important feature of the simulator. You can see we have a Intercom landing mode, blue auto thrust is speed. We have another very important feature in the simulator. Maybe you can show just do engine vibration, please. Okay, engine page, you have vibration, and it is very important that. Yeah, so it's. Did you put the vibration?
Yeah.
But activated. Yeah. Now we have engine vibration. You can see that it's flashing. The very important thing, you cannot hear it actually, but there is a seat shaker below each seat, so you can feel actually when you have a engine failure with damage, or you have any kind of damage, we put bumps so you can feel in your stomach that something is not right. It is not there for entertainment, so it is there because you have to get haptic feedback for almost everything that it's happening in the sim. So we put a so-called butt kicker in the system. Yeah, you could leave it there because I could turn that, but yeah, it's okay. So this is how it works, and it's very important that it gives you feedback when you put the aircraft nose wheel down to the runway. And this is very important because actually in a fixed base sim you have to do everything to get the pilot's attention on what he is doing. And actually because he's the main wheel touchdown, you can hear on the sound system. We have a 5.1 sound system with big subwoofer beyond that panel. But
400.
Actually when you land, when you do
300.
when you put the nose wheel down, usually you don't feel it in a fixed base sim. So this is why we added some effects that you can feel when you landed the nose wheel.
100.
Okay.
50. 40. Minimum.
Continue.
20. Retard. 10.
And you can feel when you put down nose wheel. Okay, so we have spoilers. Reverse are green, but it's a long runway, and decel with low auto brake. Okay, manual brakes. So we disable the brake by pushing the pedals a bit. 5. This is, yeah, we can exit via left. It's a rapid exit taxiway, so I will just go this one, taxi speed. Okay.
Ladies and gentlemen, welcome Bristol Airport.
Yeah.
We arrived.
Taxi. Standby. So right now we are back in Brussels airport, and because we had a quite serious failure, we just park our aircraft somewhere like, let's say, here. This is not really stand. Oh, there is a. It's just a small
It's raining.
stand. It's raining. Yeah, I can show you that we can do not only rain. Yeah. Taxi light off. Yeah, we have dynamic lighting, and we have a synchronized 60 Hz visual. No radar off, because it's important not to kill anybody on ground. Okay, we are here. Set the parking brake. We have the APU available. So engine master 1 off. Engine master 2 off. Okay. Pumps off. We have below.
Okay, we are ready.
Yeah, let's make it like. Okay. Yeah, you have that. Okay, so this completes our test flight around the simulator. I hope that you liked it.
Yeah, enjoyed it.
And enjoyed it. And well, if you have any questions about the sim itself, or about the company, or about anything, just don't hesitate to ask. You can send your questions to
sales@simnest.com, or you can visit our www.simnest.com. You can check all the information about the simulator, about our company, about the support services, what we can provide, and you can write an email to us as well.
So, this completes our first online show, and thank you for being here. Keep safe, and
stay at
I
home.
hope that we will have soon recovered from this whole not so good things we have right now. And well, thank you, and bye bye.
Thank you very much. Have a good day. Bye.